Hey guys, welcome back to my channel Alpha Geeks. I hope you are doing well and have started preparing for your aptitude exams, competitive exams, or whatever entrance exam you are hoping to clear. I hope the videos are helping you, and the upcoming videos will definitely help you in the preparation of exams, clearing all your basic needs and necessities. Even though if you have doubt, you can always contact me on my WhatsApp number or mail me on my email ID if you need any assistant on maths or anything regarding the aptitude test. You can contact me, take my help. I will be happy and delightful to help you. So today's topic, talking about today's topic is one of the most important topic you need to learn for your aptitude or competitive exams. So let's start the topic. Arithmetic progression. Arithmetic progression generally people refer it to as AP. So AP is one of the important topic where you deal with sequences and how to solve the sum or find the nth term of the sequences. This is just an overview I'm giving you about the arithmetic progression. The details will be shared in the following slides. So arithmetic progression is actually one of the important topics where you need to focus because many of the questions are asked based on progressions and the sequence. So sequence and series progressions, you need to learn those things very clearly. So before starting with arithmetic progression, I will just like you to revise your fractions. So let's go to the fractions. Fractions. I'm always telling you know your fractions because fractions will be very, very important during your aptitude or the competitive exam time. It will increase your calculation speed and will help you to calculate faster. So just go through all the fractions from 1 by 1 to 1 by 20 expressed in terms of percentages. Just remember them, just mug up wherever you see the fraction, or you need to like convert one fraction into another, or you need to convert fraction into decimals. You can always use these charts. So let's start with our topic, today's topic, arithmetic progression. Let's go towards the next slide. Concept of arithmetic progression. So basic concept of arithmetic progression is nothing but an arithmetic progression is a sequence of numbers in which each term is derived from the preceding term by adding or subtracting the common difference, which is generally we denote the common difference by d. So basically, if we have a sequence which is starting with A and A, then the next term will be A plus D. The next term, the further next term will be A plus 2D. If we want to know the preceding term of A, then the preceding term of A will be A minus D, A minus 2D, A minus 3D, and so on. So the sequence is differing. So each consecutive number is differing by a difference of D. So these type of sequences are known as arithmetic progression. They are differing by the arithmetic addition or subtraction. That's why these sequences are known as arithmetic progressions. For example, let's take an example. See here, we have given a sequence 9, 6, 3, 0, minus 3. So just check what is the difference between the second term and the first term. It is minus 3. The third term and the second term, it is also minus 3. The fourth term and the third term, it is also minus 3. So the difference is remaining constant. If the difference of the consecutive terms is remaining constant, then we can say that the sequence is in arithmetic progression with minus 3 as the common difference, because here the common difference is minus 3. The progression minus 3 0 3 6 9 is an arithmetic progression with common difference d. We have just mirror imaged the sequence. We're starting with minus 3 0, so we are incrementing each the next term by 3. So the here the common difference will be 3, and each term will be incremented by 3, each consecutive term. So minus 3, then you will increment it by 3, you will get 0, then again you will increment it by 3, 3 again incremented by 3, 6, so on and so forth. The sequence will go. So generalizing these things I have previously mentioned, if A is the first term, here A is also known as first term, and D is known as common difference. These are the generalized notation used everywhere in your textbooks wherever you will read about AP. So please remember these notations. So A is your first term and D is the common difference. If you want to derive an arithmetic progression with first term A and common difference D, then you can always use these steps. The first term of the sequence will be A, then you will increment each and every term by D. So the next term will be A plus D, and the further next term, when you add d in a plus d, you will get a plus 2d. The next term will be a plus 3d, and so on and so forth. A plus 4d, a plus 5d, a plus 6d. The sequence will go on. So this is the basic concept of arithmetic progression. So let's move ahead and learn some new tricks and tips. So, finding the nth term of the sequence. So, if we have a question to find the seventh term, eighth term, ninth term, if we know just the common difference and the first term of the sequence, we can find those terms according to the requirements of the question. Where we generally denote the nth term by by Tn. Tn means the nth term of the sequence. When n is equals to 1, it is first term T1. When n is equals to 2, it is second term T2, and so on and so forth. If you want to find the nth term of the sequence, you can always use this formula where A is the first term, n is the nth number where which term you need to find, and D is the common difference. So the nth term of the sequence will be A plus n minus 1 into D. So here, if you need to find common difference when you have any two consecutive numbers, you can always find the common difference by the next term minus the preceding term. So the common difference will always be the next term minus the preceding term. Now here sometimes the question may be to find the sum of all the numbers in the AP. Suppose 1, 2, 3, 4. Now see, the difference is of 1. So 1, 2, 3, 4 are in AP. If you need to find the sum of those numbers, you generally add those numbers 1 plus 2 plus 3 plus 4. But here if numbers are large, then you cannot directly add those numbers. The method will be very lengthy. So you find out if you find out the sequence is in AP, then you can always use this generalized formula to find sum of all the numbers in an AP. So to find the sum of all the numbers in an AP, the formula is given by n by 2 into 2a plus n minus 1 into d. So remember this formula to find the sum of all the numbers in an arithmetic progression. There is also one another formula to find all the numbers and to find the sum of all the numbers in an arithmetic progression if you know the first term and the last term. If you know the first term and the last term of the sequence, you can always use this formula to find the sum of n terms in an AP. Okay, now see, when three quantities are in AP, let's assume A, B, C are in AP. Three quantities are in AP. Then, then if they ask you to find B, B will be always the average of A and C. So B is equals to A plus C by 2. This is also known as arithmetic mean. B is also known as arithmetic mean. If any two numbers are given to you and if they ask you to find the arithmetic mean of those two numbers, you can always average out those numbers and find it. Okay, now after learning this much about AP, let's move forward to few of the examples. The sum of the first term of an arithmetic progression is 10. So here the value of a is given to us as 10 and the last term is 90. So we know the tn is what? 90. If sum of all term is 800, now we have given that all the terms add up to 800, then what is the sixth term? Now to find the sixth term, we need to find a common difference. We don't know the common difference. If we had a common difference, then we had used the nth term formula a plus n minus 1 into d and find the sixth term. So here first we have to use the formula given by the sum of all terms in an AP. So here if we know the Tn, we can easily find we have first term 2, we can easily find how many numbers are there in a given AP. So the sum of all terms of this arithmetic progression is what? N by 2 Tn plus T1 is equals to 800, where Tn is 90 and T1 is 10, given the first term of the arithmetic progression is 10. Correct? Solving this equation, we get n equals to 16. So we know that there are 16 terms in an arithmetic progression. Now we know the last term Tn, and the value of n is 16, so the value of T16 has to be 90. So here the value of T16 is what? 90. Correct? So using the formula to find the T16 term, we can say that a plus 15d is equals to 90. Now we know value of a is 10. Substitute 10 in the equation and solve it. You will get d equals to 5. Correct? You got the common difference as 5. You know the first term of the sequence is 10. Now you can easily find the sixth term. So the sixth term will be a plus n minus 1 into d, where n is 6. You will get a plus 5d. Now substituting the value of a as 10 and d as 5, you get 30. So T6 will be what? 30. Correct? Let's move to a next example. Example number 2. Let's go through example number 2. The sum of three numbers in an arithmetic progression is 45 and the product is 3000. Correct? What are the three numbers? So whenever you have to assume three numbers which are in give AP, you can always assume in this manner. The first term is a minus d, the second term is a, and the third term is a plus d. This will always simplify your solving. You can always assume as the first term as a, second term a plus d, second plus a plus third term as a plus 2d, but that will complicate your calculation, so better go with this method. Now you know that sum of all the numbers is 45. Add all the numbers, you will get 3a is equals to 45. Correct? Now solving this equation, you get a equals to 15. Now you know the value of a as 15. The second term of the sequence is 15. Yeah, now you just need to find the common difference to find the first and the third term. Correct? Now using the second condition, we can find the common difference. What it is given? The product is 3000. Now if the product is 3000, we can say that a into a minus d into a plus d is equals to 3000. If we substitute the value of a, we get a minus d into a is equals to 200. Just try solving that equation, you will get. Now what is this? This is a minus d into a plus d, which can be written as a square minus d square equals to 200. Sorry. Now substitute the value of a as 15. If you substitute the value of a as 15, you will get 15 square minus d square is equals to 200. So 15 square is 225. If we solve this equation, we get d equals to 5. Correct? So d equals to 5 is our answer. Now just substitute d equals to 5 in the above assumption. A minus d will be 5, a minus d will be 10, a is 15, and a plus d will be 20. So our three numbers would be 10, 15, 20. Correct? Now you can check it by adding those numbers. The addition of these number is 45, and you can also multiply these numbers and check the product is 3000. Okay, correct. By example 2, I'm gonna end this slide, but I want to tell you something, that in the future videos I'm also going to upload the placement scenarios in the current COVID pandemic by interviewing few of the students who have just received a job offer and are going into the company's environment. Also the previous working employees of some of the companies which I have contact in, those experience will be shared with you on this channel. So subscribe, like, and comment, and stay tuned for the future videos. Thank you.